Over the past few decades, we've found thousands of planets out there, and we're constantly finding more. Now we just need to sort through them to see which can support life. But that's easier said than done. Whether a planet has liquid water is probably the most important factor, and plenty of researchers spend their time looking for signs of it. But it turns out active tectonic plates are pretty important too. It's not easy to find signs of plate tectonics on other worlds, but we're getting there. The slow drift of the continents is probably the first thing that comes to mind when you think of plate tectonics on Earth. But what's key here is that the same processes constantly recycle elements between the surface and the mantle layer below the crust. On Earth, this is believed to have been key to oxygenating the atmosphere and keeping the climate stable over billions of years. For example, the carbon dioxide from volcanoes helps keep the planet warm. But if it gets too hot, chemical reactions between the Earth's surface and the atmosphere pull carbon out of the atmosphere and cool things back down. Without these stabilizing cycles, a planet's climate could get too hot and vaporize all the water, or too cold and freeze it. Neither would be great for life. So many scientists think plate tectonics are a crucial ingredient for the long-term survival of life on any planet. Looking at our own solar system, many of our rocky neighbors have tectonic activity of some sort. Faults, quakes, or volcanoes. But they're also all stagnant lid planets, meaning their crust has cooled into a single solid surface. We haven't found multiple plates or a continuously recycling crust like on Earth. So with our solar system ruled out, the search has focused on exoplanets, those orbiting other stars. Of course, it's much harder to study these planets since they're so far away. So to learn something about their geology, we infer what we can from the data available, mostly the overall physics of the planets and the stars they orbit. For example, what a planet is made of plays an important role, and we can say something about that by looking at the star it orbits, since they form from the same interstellar cloud of stuff. You need just the right combination of rock densities to create plates that will sink back into the mantle below other plates, and for that, the planet has to have certain elements in specific proportions. Based on this, one 2017 study looked at the composition of stars and concluded that about 1/3 could likely support planets with plate tectonics. Water can also reduce the friction between the mantle and the crust, which could be vital to keeping the plates moving. And we know water is already a near certain requirement in making a planet habitable, so it's nice that the variables line up. When a rocky planet first forms, everything is pretty much magma, which then naturally cools into a stagnant lid. To start plate tectonics, you also need enough force to break open that lid and keep the planet's crust moving. So in general, it's thought that the more stress a planet is under, the easier it is to crack open a stagnant lid, as well as keep elements moving between the mantle and the surface. On Earth, this mostly comes from the mantle's convection, the slow movement of material that transfers heat from deep within the planet to the surface. But that's not the only thing that could drive tectonics. Planets close to their stars will have higher gravitational tides pulling on them. And a 2019 study used a computer model to show these could make plate tectonics more likely. In some cases, these tides could potentially be strong enough to drive the process of plates sinking back into the mantle. Another important factor is the planet's size. A study modeled planets of various sizes and found that as a planet gets bigger, convection stress in its mantle increases. The models also showed that larger planets tend to have thinner crusts that could break more easily. That makes super-Earths, large rocky planets with up to 10 times Earth's mass, great candidates for plate tectonics. And in fact, that's where researchers found what may be the first known exoplanet with active tectonics, in a 2021 study published in the astrophysical journal Letters. It's called Super-Earth LHS 3844b, and it's 49 light years from Earth. There is a catch, though. These tectonic plates would look very different than the continents here on Earth. LHS 3844b is tidally locked, meaning the same side always faces its star. And it's in such a close orbit around a red dwarf star that the temperature difference between hemispheres is over 1,000 degrees Celsius. By building a computer model of it, researchers found that the huge difference in temperature drives movement of the planet's surface. It's kind of like how the convection in our planet's mantle is driven by heat flowing from the core to the surface, except in this case, it's flowing from one hemisphere of the planet to the other. Of course, these conditions are incredibly harsh to expect to find life in. Extreme temperatures aside, the planet doesn't have an atmosphere. But it's a start. And as we get better at observing exoplanets directly, we will only learn more. Next-generation telescopes like the James Webb Space Telescope will be able to look for volcanic eruptions by detecting small particles in a planet's atmosphere. This wouldn't guarantee tectonic plates are active, but it would be some nice, strong evidence. Extraterrestrial life isn't easy to find, but if nothing else, the search for extraterrestrial moving plates could help point us in the right direction. Thanks for watching this episode of SciShow Space. To learn more about LHS 3844b, check out our news episode. And if you'd like to support the channel, check out patreon.com/SciShowSpace to learn more.